Okay, guys, hopefully we can get through this kind of quick here. I recorded this whole thing here and then it deleted, so hopefully we're going to start from the beginning and get going here. So we're looking at absolute value inequalities, okay? And absolute value inequalities, we're going to notice have some patterns in them that we're used to seeing, okay? So we're going to start with absolute value inequalities that deal with the less than symbol, and then we're going to work our way into absolute value inequalities that use a greater than symbol, okay? So looking at these, okay, we're going to notice that absolute value inequalities that include a less than sign end up graphing, if you guys notice the graph here, like and compound inequalities. So we know we have two types of compound inequalities. We've been doing them the last couple days. If there's an absolute value sign and a less than symbol, okay, we're going to notice that these inequalities tend to graph towards each other like and inequalities, kind of like the picture shows here, okay? So we're going to skip through the rest of this table, and we're going to look at just solving these, and we're going to see that there's some type of pattern here, okay? So if I want to solve the absolute value of n plus 5 is less than 3, there are two cases I need to consider, okay? Case 1 is really just as easy as rewriting this inequality here without the absolute value signs. So case 1, I can just kind of remove the absolute value signs, and I would have n plus 5 is less than 3. Well, if I wanted to solve this inequality for m, that should be a pretty process to do, or pretty easy process, excuse me. So I would subtract 5 from both sides, and I would get m is less than -2. So case 1 is done. That's all case 1 is, okay? Now case 2, when we do case 2, it's almost the exact same process. It's just this time we're going to take our stuff that's on the left, and we're going to multiply it all by a negative sign, which means I'm going to take it times -1. So -1 times m would give me -m, and -1 times 5, excuse me, would give me -5. So now I need to solve this inequality for m, and we're going to notice hopefully that this process might take us a few more steps, but it's really not too challenging, okay? I start by adding 5 to both sides, and I would get -m is less than 8. And then to get m completely isolated, because it's not right now, I would need to divide both sides by -1. And of course, the process of dividing by -1 would cause me to flip my inequality, okay? So once I do case 1 and case 2 and solve for my variable, I would end up with m is less than -2 and m is greater than -8. So I have two inequalities here, and when I graph them, kind of like I was saying earlier, we're going to notice that they're going to end up graphing like an and compound inequality, right? There's those two types of compound inequalities, and inequalities graph towards each other. So we're going to notice when we actually graph these, m is less than -2 would be an open circle at -2, and it would go left. And m is greater than -8, it's an open circle at -8, and it would go right, and there's that intersection point right there, okay? So example 1 kind of really shows us that if it's an absolute value inequality and is containing a less than symbol, okay, and it could also be less than or equal to, less than and less than or equal to, they end up graphing like and inequalities towards each other, okay? Now if we look at example 2, we have the absolute value of n minus 5 is less than -5. Now there's some problems with this one, right? We want a value that is less than -5, but we're taking the absolute value of something over here, okay? So no matter what number we pick, even if it ends up being a really big negative number, if I take the absolute value of that, my remaining number is always going to be positive, meaning no matter what, if I pick a value here, it is never going to be less than -5 because of these absolute value signs. So hopefully, okay, hopefully we notice that if there's no possible answer for this problem, hopefully we remember what my answer would be here if we have no possible answer here. Hopefully you guys are all saying in your heads no solution. The answer for example 2 would be no solution, because it is not possible for the absolute value of n minus 1 to be less than -5 because of the absolute value there, okay? Hopefully that makes sense, okay? So the big takeaway with absolute value inequalities and less than symbols is that if you can graph them, they end up looking like our compound inequalities, specifically the and inequalities where they graph towards each other, okay? We're going to skip example 3 today, okay? We're going to skip example 3, okay? We're going to go into the second type of inequalities we're working with today. These are absolute value inequalities that involve a greater than symbol. And again, this can be greater than or equal to. And we're going to notice when we graph these things that they look like our second type of compound inequality. Okay? They graph away from each other, which means they end up actually looking like our or inequalities. Okay? And again, you guys have these pictures and those tables in your notes. That would be something I would be referring to when I look at graphing these or solving problems, okay? Excuse me. Okay? So let's take a look at example 4. Example 4 will be the last one we do today, okay? Example 4 will be the last one we do today. We're going to skip example 5 on the bottom of the second page there, okay? So I want to solve the absolute value of 2m minus 9 is greater than 13, and I need to do case 1 and case 2 again, and I need to graph it. Okay? Well, case 1 and case 2 are the exact same as case 1 and case 2 that we were doing before. Okay? In case 1, remember, we can just remove our absolute value symbols. Okay? So that's what I do in this first step here. I just remove the absolute value bars, and now I can solve for m. To solve for m, I would add 9 to both sides. I would get 2m is greater than 22, and then I would divide both sides by 2 to get m is greater than 11. M is greater than 11. That's case 1. Pretty easy again, right? It's a two-step inequality to solve for a variable. Pretty easy. Now case 2 is the exact same setup, except I'm going to multiply my stuff on the left by a negative 1. Okay? I'm going to multiply my stuff, which in this case is 2m minus 9, by a negative 1. So I start this problem by distributing a negative 1 to get negative 2m plus 9 is greater than 13. And now again, the process here, I'm going to solve for my variable. So I'm going to start by subtracting 9 from both sides, and I would get 13 minus 9 is 4. And I would get negative 2m is remaining on the left side here. To solve this inequality, I would divide both sides by negative 2. Hopefully you guys are not screaming at your computer screens, but you know, in your heads telling yourselves, well, we're dividing by a negative number. We need to flip the inequality. So I would have m is less than negative 2. Okay, m is less than negative 2. So my two inequalities I would have here would be m is greater than 11 and m is less than negative 2. Okay, that was case 1 and case 2. Now we just have to graph this thing. Okay, again, greater than inequalities and absolute value. So if there's an absolute value with a greater than symbol, they're going to graph like our compound inequalities, specifically the or type where they go away from each other. So m is greater than 11, open circle at 11, arrows to the right. M is less than negative 2, open circle at negative 2, arrows to the left. Okay, so we just need to be able to recognize, is there an absolute value and what kind of inequality do I have? And then we can kind of get an idea of how they're going to look on a graph. Okay, so again, that was the last one we're going to do today for our notes. You guys should have some time to do the worksheet, hopefully. And then if you have any extra time, remember your MyPath is due tomorrow, December 20th. Okay, have a good day, guys.